All right, so you're ready to really level up your problem-solving game, right? We're diving deep into computational tools that'll blow your mind, especially if you're just getting started in science and engineering.
And we have the perfect guide for this journey.
Yeah, Professor Barba.
Exactly.
She's like a total rock star in this field.
Yeah.
She's going to break down Jupyter for interactive computing.
Yes, and those essentials of Python strings and lists.
Like your foundational toolkit for all things sciencey and engineering.
They really are the building blocks for harnessing the power of computation.
I'm already geeking out just thinking about it.
Mm-hmm.
Professor Barba makes Jupyter sound almost magical. Like you can write code, run it, see the results, add explanations, visuals all in one document.
Yeah.
It's like a scientific notebook, but like on steroids or something.
That's a fantastic way to put it. It really has revolutionized scientific workflows.
Wow.
Jupyter notebooks are like this live document that evolves along with your research.
Oh, cool.
You blend your code, your findings, your entire thought process. Game changer for collaboration and reproducibility, too.
So no more clunky software, no more separate files for code and documentation.
Yep.
It's all just right there in my browser.
That's the beauty of it. And it's surprisingly user-friendly.
Okay, good.
At the heart of it all is Jupyter Notebook.
Okay.
This is where you actually write your code and you see it come to life.
I like that.
It has all these cool features,
Okay.
like a built-in debugger to help you squash those pesky bugs,
Yeah.
and a table of contents to keep everything organized.
A debugger.
I know, right? That's the beauty of Jupyter. It's designed to be accessible, whether you're just starting out or you're a seasoned coder.
I like that. Okay, so let's zoom in a little closer and see how these Jupyter notebooks actually work.
Okay.
Professor Barba mentioned something about cells and modes. I'm picturing tiny prisons and different ways to feel, but I'm guessing that's not quite it.
Not quite. Think of cells as like the building blocks of your notebook.
Okay.
You have two main types. Code cells, where you write and run your Python code.
Okay.
And then you have markdown cells, where you add all your explanations, format, your text, basically make it all look nice and readable.
Markdown. That sounds kind of familiar.
Yeah.
Isn't that like a simpler way to do all the fancy formatting instead of wrestling with like HTML tags and all that stuff?
Exactly. It's a lightweight markup language, super easy to learn.
Oh, cool.
You use simple symbols to create headings, bold text italics, links, all sorts of things.
Nice.
Professor Barba actually recommends a website. It's called Daring Fireball for a quick markdown crash course.
Okay, bookmarking that.
Yeah.
So I can use Markdown to explain what my code is doing.
Yep.
Add some context, maybe throw in a funny GIF or two.
You got it. Make your notebook engaging and informative.
All right. So this is starting to sound a lot less scary than I thought it would be. But how does the actual coding part work?
So the real magic happens when you run your code cells. You type your Python code into the cell, you hit Shift plus Enter, and boom.
Yeah.
The output appears right below it. It's instant gratification for your coding efforts.
Whoa. So no more waiting for ages for a whole program to compile.
Nope.
That's a huge time saver.
It is.
I can already see how this interactive approach would make learning and debugging so much easier. It's like having a conversation with your code.
Exactly. It really is like a back and forth.
Yeah, I like that.
And speaking of conversations, Professor Barba actually compares working in Jupyter to using the command line, but in a much friendlier way.
Ah, the command line. I remember my first encounter with that. It felt like I was trying to communicate with an alien species. Lots of cryptic symbols and blinking cursors.
Right.
But Jupyter makes it more human readable.
Exactly. To really showcase Jupyter's power, Professor Barba dives into the world of Python strings.
Strings.
Yeah.
Those are how we handle text in Python.
Yes.
Like if I wanted to store a sentence or a tweet or even like a whole book chapter, I'd use a string.
That's exactly it.
Yeah.
And Professor Barba starts with some basic operations like concatenation.
Concatenation?
Combining strings together.
Okay.
Like building sentences from words,
Yeah.
but with code.
Got it.
So if I wanted to combine the strings hello and world, I could just add them together with a plus sign in Python.
That's easy enough.
It's that simple.
Okay, that makes sense. But then things always seem to get a bit trickier when we start talking about indexing and slicing.
Yeah.
It's like we're suddenly speaking a different language.
Yeah, I get it. But think of it this way. Indexing is like pinpointing a specific letter in a word.
Okay.
And slicing is like grabbing a whole chunk of letters.
Okay, that analogy helps. So indexing is for getting a single character and slicing is for getting a whole section of a string.
You're catching on quickly. And here's where it gets a bit interesting.
Okay.
Professor Barba emphasizes that Python uses zero-based indexing.
Zero-based indexing. Okay, now I'm officially confused.
I know it might seem counterintuitive at first, but it's how Python rolls.
Yeah.
It means that the first character in a string has an index of 0, the second character has an index of 1, and so on.
I guess it's kind of like how apartments in some buildings start with 0 on the ground floor.
That is a great way to think about it.
Yeah.
And Professor Barba actually offers this really neat visual.
Okay.
Imagine the indices as pointing between the characters, like little flags marking the spots.
Oh, I like that. So to get a specific character, I just use its index in square brackets.
Yeah.
And to get a slice, I specify the starting and ending indices, like setting out those flags to mark the section I want.
Precisely. And if you want to slice from the beginning or to the end of the string, you can just leave out the corresponding index.
Oh, okay.
Very flexible.
Okay, so this is starting to click. So we can grab individual characters, extract words, even play around with negative indices to count backward from the end of the string.
Exactly. You're getting the hang of it.
But strings aren't all we can manipulate in Python, right? Professor Barba also mentions lists, like those to-do lists we all love and rely on.
Right. But in Python, lists are much more than just to-do lists.
Okay.
They're these incredibly versatile containers for storing and organizing sequences of values. Think strings numbers or even other lists.
Oh, wow.
All neatly tucked away in a list.
Wait lists within lists. That sounds a bit mind-boggling, like those Russian nesting dolls.
It's very much like that. And Professor Barba shows how to create lists using square brackets and commas. You can mix and match different data types within a list, and yes, you can even have those nested lists you mentioned.
So it's like having different compartments within a bigger container, and each compartment can hold all sorts of things. I'm starting to see the power of this.
And just like strings, you can access elements in a list using indices and slicing.
Right.
Remember that zero-based indexing applies here as well.
Okay, so it's the same concept, just applied to a different type of data structure. I'm sensing a theme here. Python likes to keep things consistent.
Absolutely. Consistency makes code more readable and predictable.
Yeah.
And like strings lists come with their own set of methods for manipulation.
Oh, cool.
For instance, you can add elements to a list using the append method, modify existing elements, or even check if a specific element exists in a list.
So it's like having a toolbox specifically designed for working with lists. I can already imagine all sorts of cool things you could do with this, like sorting data filtering items or even building up complex data structures.
Exactly. But Professor Barba points out a key difference between strings and lists that often trips people up.
Okay.
Strings are immutable, meaning you can't change their characters once they're created.
Yeah.
Lists, on the other hand, are mutable.
Yeah.
You can modify their elements to your heart's content.
Ah, that makes sense. It's like the difference between a printed book where you can't just erase and rewrite words and a whiteboard where you can change things as much as you like.
That's a perfect analogy. It highlights the distinction between immutable and mutable data types.
Yeah.
And it connects beautifully to the interactive nature of Jupyter notebooks.
Oh, nice.
You can see those list modifications happening right before your eyes in real time.
Now, that's what I call interactive learning. But Professor Barba doesn't stop there.
Nope.
She goes on to talk about iteration and conditionals, which sound like even more powerful tools. What are those all about?
Well, think of iteration as automating a repetitive task. In Python, the for statement lets you repeat a block of code for each item in a sequence, like stepping through a list and doing something to each element.
Yeah.
So instead of manually copying and pasting code for each item, you can just use a for loop to automate the process.
That sounds incredibly efficient,
Yeah.
especially if you're dealing with large data sets.
Exactly. And Professor Barba emphasizes the importance of indentation in Python.
Yeah.
It's not just about making your code look pretty, it's how you tell the interpreter which blocks of code belong together.
So indentation is like those invisible fences that keep everything organized and in its proper place.
That's a great way to think about it. And along with the for statement, there's this handy function called enumerate. It lets you keep track of both the index and the value of each item as you iterate through a sequence.
Okay.
Imagine you have a list of names and you want to print each name along with its position in the list enumerate. Makes that super easy.
Okay. I'm starting to see how these pieces fit together. But what about conditionals? How do those play into this computational puzzle?
Conditionals, they're all about decision-making in your code. Think of them as if this, then that logic.
Okay.
Python gives you if, elif, which is short for else if and else's statements, to create these like branches in your code.
Okay.
So different actions can happen depending on whether certain conditions are true or false.
So it's like setting up rules for your code to follow based on different scenarios.
Yes.
Like if it's raining, take an umbrella. If it's sunny, wear sunglasses.
That's a great analogy. Professor Barba gives these examples of like checking if a number is positive, negative, or zero, and then doing different things based on the outcome.
Right.
It's how you add that intelligence and flexibility to your programs.
Okay. I'm starting to feel like I'm getting a handle on these computational building blocks. But how does all this strings, lists, loops, conditions, how does it all come together to solve like real-world problems?
Well, Professor Barba leaves us with this challenge. Imagine you have this massive data set of texts, like tweets, scientific articles, or even an entire library of books.
Wow.
By combining what we've learned, you can start to extract these meaningful insights from that data.
So I could write code to search for specific keywords.
Yes.
Maybe analyze the sentiment of tweets, see if people are generally happy or grumpy about a certain topic.
Yeah.
Or even track how language use changes over time in scientific literature.
Exact.
That's fascinating.
It's like having this digital detective sifting through mountains of information, like covering these hidden patterns and trends, and the possibilities are endless. They're limited only by your imagination and the questions you want to answer.
Wow. Professor Barba has truly opened my eyes to the power of computational thinking. It's not just about crunching numbers. It's about using these tools to explore, analyze, and understand the world around us.
And remember, this is just the beginning of your computational journey. The more you experiment, the more comfortable you'll become with these concepts. Professor Barba encourages everyone to just play around with Jupyter notebooks, try out different Python code, and see what you can create.
So to recap, we've gone from feeling a bit intimidated by Jupyter and Python to understanding how these tools can be used to solve real-world problems, all thanks to Professor Barba's insights. We've explored the magic of Jupyter notebooks, the flexibility of Python strings, and lists the power of loops for automation and the logic of conditional statements. We've even started to imagine how we can use these concepts to unlock the secrets hidden within massive data sets.
And the key takeaway is don't be afraid to dive in and get your hands dirty. The more you explore, the more you'll discover the incredible power of computational problem solving.
Well, that's our deep dive for today, folks. We hope you're feeling inspired and empowered to start your own computational adventures. Remember, knowledge is power, especially when it comes to wielding these amazing tools. Until next time, keep exploring, keep learning, and keep diving deep.